Thank you, everyone. I'm Chris, or Tizot, or Zot, whatever you want. I've been with Yodek for 8 years. When I joined the company, I was the sixth employee. Now we're more than 150, so we've lost count. What else? My first Unix account was opened in 1987. I'm older than I look. And the first time I saw Python code was in 2000. That's more or less the basic stuff you need to know about me. So, what we are going to talk about. Yep. Migrations. Who among you have ever worked with Django migrations? Can you? Yeah, great. In any case, I will give a small heads up so that everyone knows what we talk about. Well, you have your code, which has versions, is under source control, usually Git. And you also have a database server, which must be in sync with your code. Now, the device we have for space and time traveling is Git. You can go back in time, go forward in time, or move 2 seats to the left and have the same version of the code. The database does not work like that, so the easy answer is you record the changes to the database schema as code, which is, along with the other code of your application, stored inside Git. So, when you have to, so you have your code and the changes to the database that go with it. If everything was perfect, then you would have a straight line from the past to the future, and you could go back to any point whenever you want. However, we have branches. We have things that work in parallel, which means that if you are in C2, the branch C2, and you want to go back to B1, you can do it with one command in Git, but in the database, you have to undo the changes C2, C1, A2, A1, so you are before B1, and then apply the change for B1. This is the way to change branches and have your database follow the changes. Well, what you can do is do it by hand. You see what I'm here, those files changed, so I got to go back there, etc. Obviously, this can be automated. Also, another thing that is important is that not all changes that not every migration file which is stored in by Django migrations, or South as the module was used to be called, they're not all about the database. Some information is only Django. So, like, for example, when you have a default on a field, Django does not apply the default as a database change. The code itself, the framework, manages the default. So you might change the default, and by default, the migration framework would make a new migration just to record this change. This is not a database change, so you don't really have to move back the database in any version. And another thing is, you might have choices in a field which is used by in the admin framework, which we call Y console, but it's not important. So you can, if you make a change in choices, you have a field with choices, and in the admin framework, you would see a drop down with the choices, and then you add a new choice. That would cause a new migration to be created, but it's only for Django. It's not for the database. So one thing we do is we store the choices in another module, which is accessible both by models.py and by the migration itself. So they both import the same setting. And if you change the setting in the imported module, then both the models and both the migration show the same content. So Django does not create a migration for that. Now, another thing we had, um, especially with Django 1.8, we used to work with Django 1.8 in the beginning and with Python 2.7. Before we managed to go to Python 3.8 and Django 3.2, and we managed for some months to have the exact same code base for both versions of both Python and Django. There was a bad algorithm in Django's migration management. So we used to merge migrations. This is the official way to, if you have one migration and another migration which are not related, you're supposed to make a merge migration that joins the two. And we used to have a lot of merges because we had a lot of parallel development. The thing is that with many merges, especially if you had references from one Django application to another, that algorithm used to inefficiently count all possible paths in a list. The code on the left is from the Django migrations framework. There are two prints marked with a comment with my username. And you will see on the right a sample run that we arrived at a point where those collected migrations reached up to 35 million. So migrations used to take a lot of time. We made a patch for internal use because by then 1.8 Django was already out of date. So we made the patch for our use until we switch over to Django 3.2, where the algorithm was corrected. And so this is one data point that affected our choices of procedures and tools. At first, we thought, okay, merges are not very efficient. So we thought, why not make all migrations serial? It's kind of Git rebase, but not exactly. What we did is we have a registry where each one goes and places dibs. I want this number of migration. And they use that number in their branch, pointing to whichever was the last migration before the branch. We do that so that we have one migration next to the other. We also try to have self-sustaining migrations, meaning it goes forward, but it can cleanly go back. We have tools that help us. For example, if you add a table and then you have to go back, the table will get dropped when you get back, but you will also lose the data of the table. If you had something you wanted to preserve when you come forward again, we also have tools for that. You mark the interesting data in your migration. We have code that creates two functions. In this case, one function is called save data before updating parent folders on the left and the bottom, and the top right is the restore save data if any. This is an actual sample for one of our migrations, which has also the guidelines, because you have to keep in mind that when you move forward, the order of the operations is on the left. But when you go backwards, the order is reversed. You go from bottom to top. And given that Postgres, which we use in a single transaction, does not allows data changes only after schema has changed. If you change a table, you cannot add data to it or to anything else in that transaction until the schema change has been committed. So we make sure that all changes to the database tables or fields, columns, happens before we make data changes. So this is another point which we try to enforce, is that each migration is self-sustained and has the correct order of operations. So to handle all those going back and forth, we made some tools. One tool is switch to. You're in a branch and you want to move to another branch. So you say switch to the target branch. Well, the first iteration of switch to did something simple. Just compared, I'm in this branch and in that branch, and then we have those commits that affect migrations, and we had the option that if someone added a comment with switch to ignore, then switch to ignore that commit because it was changed like the ones I said earlier that does not affect the database. But we've usually forgot to add that comment. So the switch to algorithm changed a little and said, if any commit has switch to ignore, then don't do the operations, but that wouldn't work because obviously once there was a single switch to ignore, then you wouldn't take account of all the changes. So that didn't live for long. And we ended up with the following option. We take all migrations that have changed between the two branches, we parse them, and we make an AST. We remove any operation that does not affect the database, like changes of the choices of a column. And then we compare the two trees. And if there are changes, then we know we have to go back to the immediate parent of both versions of a transaction. An example is V75 is just the name of the current release branch. So if I am in master currently, and this morning actually, when I finished the presentation, and you have to go to V75, there's only one change. There's a migration in V75, which we don't need to do anything else. We just go forward. And below is the output of the next tool I will describe, which checks exactly that and does the migration. If you go back to master, then obviously you have to go to the immediate parent of both the versions. So this is why the tool as output has the commands you need to run. It doesn't run them because we want to check, we want to make sure, and we don't all of us use the same commands. And another example, if I go to 4 releases back, then obviously the changes are much more. And you see, many of our Django applications need to go back even one in the beginning, 0. In the end, you see auto-migrate, which is the other tool I'm going to talk about. Actually, since we put migrations in a line, then it's possible that I am at migration 1. Someone branches and make migration 2. They got dibs on 2. And later, we add another one, which is 3 in the main branch. So the main branch knows 1, and 3 is its immediate child. And then sometime the two from the other branch will get merged. So we will have in the main branch migration 1 applied, migration 3 applied, and then 2 appeared, which is not applied. Django migrate, manage.py migrate cannot handle this. Says, okay, you have 2, it's not applied, but 3 it is. So we did auto migrate, which does a little magic, like finding what needs to be hidden so that migrate works. So in this example, I should hide the 3, which is already applied. So Django sees I have migration 1, it is applied. I have migration 2, it's not applied. I can apply it. There's no 3. And then 3 reappears to continue the process should it need to be continued. An example of that is actually we moved to a branch where 320 appeared. So 318, the previous one existed, 321 was applied. So it did exactly that. It hid 321, migrated to 320, then it showed and hid 321 to make sure that everything is complete. It works. It's our way to handle the less possible hassle for migrations. So, in summary, we make sure that our migrations are self-sustained. You can move forward, you can move back, because we often need to go back and forth in change branches. So we check the PR or whatever. We decided that merges were bad. They're not bad, but there are cases when they make things much slower. So we found a mechanism with the registry to avoid merges. And then we had a tool that handles the case where you have migrations and then a branch gets merged. So a migration appears in the middle. So you have to hide the rest, apply that migration, show the rest, and repeat the process should the need be. That's my great. She's great. Hmm. Um, we will have a Q&A session, as far as I know, but since, how much time do we have? Okay, this is good. Well, I was told by our HR department that to remind everyone that we are interested in people that would like to work with us. We have a very good environment. If anyone objects, they will get fired. So believe me. So this was an after credits slide. Uh we really want people that want to work with us. We really are a good environment. Um I usually, when I say stories to my wife, she gets mad because she's not in a very good company. And yeah, that one on the bottom right, it was AI created for me. The one on the top right is the one that says we want more developers. The one on the bottom is that guy over there, which used to be the backlog manager whenever we had meetings. And now he's the official closer of meetings. There's no meeting closed unless he says, yes, us. Um, on the bottom left is some people idea of fun, because I said whenever we work in our branches, I don't want to say every time in what department I work for as if I am a client. So they added my face for the skip button. On the top left is because we are so great a company, we almost have a religion. We make human sacrifices to Cthulhu so that we have a strong year. If you come and you're not a very good developer, we can sacrifice you to Cthulhu. So that's it.